So we have a car on a level road. So road has friction and everything. So what we are trying to do here is we are trying to get an expression for the velocity with which the car can turn over there, move over there basically. So let me explain this way. Say we have a circular road. Of course, this can be part of some road like this, but we'll consider imaginary. It has a complete circle, and we have a car, and this road has a center and the radius is r. So this is accelerated towards the center because of friction. Okay, so r is the source of this is basically frictional force, which is pointing inward, right? So we have to figure out mg. This is reaction force, that will be your acceleration towards the left, and frictional force will be the cause of it actually. So we have your frictional force also over here, f of k. Okay, so let me put it this way. See, whenever you're trying to drive, so whenever you try to take any turn, right, the car tends to go away, not exactly away, it tries to go straight. So it feels like it's going away from the center. Technically it's going away from the center itself. So it's going to happen. The one thing that will keep from this happening is your friction. So when it's wet, or if the road is oily, then you can see it skidding and all of that. In movies you would have seen it, or hopefully not experienced that bad, didn't have that bad experience, but still had some experience. So we skid. I mean, I fell when it's raining continuously, and it's just walking. Actually, I was just not running, but I took a big step. So yeah, I did have a fall. 2 or 3 times, I guess. So point is, this happens, right? The skidding part. But the skidding part is prevented by friction. So what is friction? Friction, it tries to provide a force which will try to stop some relative motion between the surface. Okay, so when we are trying to go away, right, the skidding tries to make the vehicle go technically away per se. So what will friction do? It will keep it inward. It will keep it in. That's why you are able to bank in a road. Sorry, not bank. You are able to turn in a road. So good roads, there are certain conditions that we'll be seeing that. So in the next video, but now we're looking at a very simple case. We have a flat road. So if I view from the ground level, like if I happen to sleep and look at the road, so it will look like a straight line basically. So from the top it might look like this, but exactly if we happen to lay down and look at it, right, it'll be a flat surface. So this is that kind of road that we are looking at. So that has to be very clear. What kind of road are we looking at, and what's that we are doing over here? So friction is the one which will try to keep it inward. If not, it will go tangential. All of this is something that you have to be very clear. If you happen to cut, say, I'll show this video also actually. I meant to say I'll be showing this video. I don't know why I said video actually and all of that. Okay, chalo. So this is for 9th graders. Not that. Yeah, I guess you can see a bit. So when I do leave it, can you see that? it goes tangential. Okay, it will go tangential. So that's the point. Even car does that. And the thread here, the thread force is replaced with, when the car, in case of the car, it's the friction. Okay, that was a good one, the last one, that is. So all of this, I hope you guys remember this from your previous grades. So that, what is preventing the car going straight in that manner is your friction. Okay, so this is the entire diagram scenario. I'm not writing a lot of things over here. So I'm not writing the mass over here as m. Let's consider a car with mass m moving along a circular path of radius r. I'm not writing those statements. Please do write those. So consider a car of mass m on a, all of that you guys have to write. Okay, so that is your starting statements. Again, our agenda over here is to figure out the velocity. Okay, what is the maximum velocity? Getting an expression for. Goal is to, aim is to expression for maximum velocity. So what is the speed limit? Okay, we are basically looking at the speed limit, 60 kilometers per hour. So basically what is the speed limit is what we are looking at. Okay, so that's the basic agenda. Right, let's have a look. Now first is we'll apply Newton's second law, that is the force, the sum will give us mass into acceleration. So now we'll apply along the vertical. So along the vertical we have r minus mg. Of course it's not going upar niche, so we have r is equal to mg. Right, next we have along horizontal. Okay, I don't need that, I guess. Let's see. So we are trying to figure out the maximum velocity. So we know that this is to do with VC calculation. So we know that force, the centripetal force is given by m into AC, and this is nothing but v square by r, and this force is nothing but your frictional force. Okay, so frictional force has to be greater than or equal to your mvc square by r. If not for this condition, it will skid. If not, the car will skid. Okay, so we are getting an expression for VC square, which will be less than or equal to Fk R by M, but we know Fk is mu k into your reaction force or normal force, whatever you guys want to call it as. Of course I'll call it as reaction force because that's what I've taken. So we have Vc square is equal to less than Fk mu k. Mu k, R is what, guys? R is mg times of R by M. So M and M gets cancelled, and therefore we have Vc less than equal to root of mu k g times r, right? So that's your general expression, case maximum velocity. So we have Vc max should be equal to obviously root of the maximum value over here is mu k g into r. So it purely depends on your friction, coefficient of kinetic friction, the gravitational pull and the radius, right? So from here we can infer that. So you need to write that. So it's directly proportional to root of mu k, gravity and radius. So basically if I have a circle which has a bigger radius, I can go faster. Again, all of this you guys have to experience. That's your homework. So your homework is experience this. Okay, so that's your homework. So when I tell experience this, you can what you can do is you can maximum you will be able to look at mu k, that is how the road is, tire will be the same, you are on the same vehicle, the radius, so the banking basically, if you are near some of the ring roads and the airports or any major highway roads wherein there is a turn, so you'll get that banking and they're pretty huge, so you can go pretty fast and people do go very fast. And when you go in a nearby town and you have those circles, there you can see the speed, right? It's around 20ish, if not for the traffic maybe 30 maximum. But on the big roads, ring roads and the near the airport or any major big fat important places, you have big circles. So there people are at least 40, 50, 60 kilometers per hour speed, right? So such things you need to experience. See guys, all of this is, it's an expression, big deal. But the thing is, all of these are very practical, as in it's something that you can experience. Most of the topics you will not be able to experience, at least not every day. But in science, bio, chemistry, physics, maths, you can experience. Actually, wait, I'll correct myself. Honestly, pretty much all the subjects can be experienced. Maybe not quantum physics, but everything else can be experienced. Honestly, it will make sense. The subject will make sense and the formulas will make sense only if you get through that. Okay, if not, just don't by heart this. It's no point.